Hello, everyone. My name is Snigdha Sarkar, and I'm Simulation Practice Lead at KETIV Technologies. Today, I'm very excited to be talking to you about artificial intelligence and how we can leverage it for making our day-to-day simulation workflows faster and smarter. Now, the idea of this presentation is to share with you some common examples and ways in which I use AI tools on a day-to-day basis. The objective is to improve productivity, process, also effectiveness. We're mostly going to talk about GPT tools, but that's not to say that AI is limited to being a virtual assistant. Let's talk for a minute about the power of artificial intelligence and how it's transforming simulation overall. GPT is not the only tool available in the ANSYS ecosystem. ANSYS, now a Synopsys company, wants us to leverage AI at all different levels of simulation in its ecosystem. So for example, you have things like ANSYS Sim AI, which can allow you to run extremely fast and physics-agnostic predictions based on training models from your previous simulation repository. Similarly, you have things like ANSYS AI Plus, which are add-ons that can integrate well with individual physics and solvers to enhance your overall simulation experience. But even if you're not using these heavy-duty AI products, your day-to-day efficiency can be greatly improved with offerings such as AnsysGPT and ChatGPT, and that's what we're going to focus on today. Now, there are certain commonalities between both AnsysGPT and ChatGPT. Both are large language models. They both use GPT developed by OpenAI to understand and generate human-like responses. So it becomes very natural, easy, and interactive to ask a question and get a response that you can truly understand. Some of the common ways in which GPT is being used today is to not just retrieve knowledge and information, but to summarize it. And then also a common application is coding and automation so that you can reduce repetitive tasks and also customize applications and solvers as needed. Now, there are certain commonalities, but there are also differences. AnsysGPT is more simulation focused. It's also ANSYS owned and licensed with ANSYS products. It integrates well with flagship solvers like Fluent and Mechanical, and it'll give you guidance on simulation setup, meshing, boundary conditions, etc. It understands engineering physics because it's trained on the data that exists in ANSYS archives, help guides, user manuals, theory guides, ANSYS learning forums. All that information is centralized and used as a source for ANSYS GPT responses. The other major difference is that ANSYS GPT doesn't store, use, reuse your queries. Now, these are differences when you compare it with ChatGPT, which is a more general purpose, publicly available AI assistant. It's not a simulation solver, although it can assist with some simulation solving capabilities. It explains concepts broadly. It also has access to a much larger database because it's pulling information from the web. But there are concerns about privacy, data breach, and you don't know if your queries are being used for further training of these AI models because these are generally not domain governed. So the way you use AnsysGPT and ChatGPT could be different. You could use AnsysGPT for getting simulation guidance. ChatGPT is a little bit more interactive, so you can really customize it for automating some of your tasks. And hopefully with the examples that we share today, I'm able to elaborate some of those differences. Now, before we dive into the examples, it's very important to note that there are certain risks whenever you use GPT tools, so it's important to use them responsibly. The first thing that you will notice if you launch a ChatGPT window is that disclaimer of ChatGPT can make mistakes, so always check the information. That is extremely true. the responses that a GPT tool provides to you is only as good as the source from where it's accruing all the information. So if the source is not good, then the response may not be 100% correct. So it's up to the user to validate these responses, to have a set of personal checks and balances to make sure that the GPT suggestions or recommendations are correct or can be practically implemented. The other things are, bias and fairness, over-reliance and misuse, ethical and legal risks. If you're um, finding responses in ChatGPT that may be subject to copyright, but then you then yourself go on to share it publicly, then that may cause some downstream issues. But one of the more important risks is to always ensure that you sanitize your data before sharing anything with GPT. It's especially important for companies like us. We have a lot of customers. We want to make sure that everybody's proprietary data is remaining confidential. So we have to be very careful when posing questions to GPT tools so that no privacy is breached. Now let's start with an AnsysGPT example. We're going to show you how to use AnsysGPT within an Ansys app. It's also called the Ansys Engineering Copilot. And let's go ahead and see this example over here. What you see on the screen is my Fluent window, Ansys Fluent window for 2025 R2. That's the version from which you will be able to avail this Ansys Engineering Copilot within the GUI. So if you look at the Learning and Support tab, you'll see this Ansys Engineering Copilot option, which opens up this panel on the side. This is basically you being able to access Ansys GPT within the tool as you're setting up the simulation. You do have to log in using your Ansys ID, but as you set up your simulation, you can ask your questions, and that makes the simulation setup that much more streamlined. You do have other resources as well, like Learning Hub and help guides, but I think those were contents that were already available in the previous versions. So let's go ahead and see this example. So we have a Fluent case loaded in here. It's a VOF problem, and I need some answers about VOF setup. So I go to the Fluid section of the AnsysGPT query box, and then I type in my question on how do I set up a VOF tank filling problem. Now, I was not very specific with my question, so it's giving me some general information about how to set up a VOF problem in the fluids family, but we can rephrase the question and make it more specific to this solver, which is Ansys Fluent. So that's what I do over here. And now we get more relevant instructions that pertain to this particular GUI. You'll also see numbers right next to the information, and those are references. If you click on them, you should be able to look at the direct sources and validate for yourself if the information is correct. Now, here is another example where I ask GPT to help me craft an expression for a transient velocity inlet boundary condition. So it has given me this expression as a prediction, and we'll see later on if this works out. But the logic is, below a certain timestamp, you have a certain velocity, and after 3 seconds, you have a different velocity. So let's see if this works later on. And then I ask a few more questions about the kind of PV coupling that is recommended for VOF problems. It summarizes the answers well from the theory and the user guide. And then I also ask a question about how do I set up adaptive mesh refinement inside Fluent. And if you stop and read my answers, or rather AnsysGPT's answers, you'll see that they're pretty accurate and relevant. Now, I've asked all these questions and we've seen how much help we can gain from leveraging this AnsysGPT tool. But let's try to copy paste the expression that it had suggested earlier into the expression box to see if it works. So I'm just going to copy paste that expression directly. And immediately you see a red box, which indicates there's something wrong with the syntax. Upon further investigation, you realize that time is not the name of the variable. It should be flow time, so you go ahead and then correct it. And once you have the right syntax in there, you should be able to compute a value for this expression. So it even tells you that the current value according to the current timestamp is 2 meters per second. This was an important example because even though the expression that AnsysGPT provided was logically correct, the syntax wasn't. And that's what I meant about exercising caution when directly trying to use or implement GPT responses into your simulation setup. You always have to make sure that one, it is accurate. Two, if there's something that needs to be fixed, you may have to do some manual research yourself. Okay. So this was AnsysGPT, by the way, not only available inside the flagship solver apps, but you can also just log on to AnsysGPT, sign in with your Ansys ID, and access the same GUI to ask your questions. It's a great way to browse through Ansys resources and documentations quickly. Now, this was AnsysGPT. Let's talk a little bit about ChatGPT. The most common and the easiest way to use ChatGPT is to use it as a smart lookup tool. So that's exactly what we're going to do here. Somebody is curious about whether ANSYS has any capabilities to model plasma simulations. So let's ask ChatGPT if it can point us in the right direction. So not only does it confirm that yes, ANSYS can do plasma simulation, it actually gives a breakdown of different applications and which tools are right for those applications. Now let's further confirm this answer by asking for some publications and sources that can demonstrate ANSYS being successfully used for plasma sims. And there you go. We have a list of papers along with the sources to read ourselves and then see how ANSYS has been used for plasma simulations. Now, what if you didn't have the time to read through all these papers? You can also use ChatGPT to summarize papers for you. In fact, it's a very common way ChatGPT is being used in the scientific community. And we're going to upload a paper. And then ChatGPT is going to summarize it for us. For the sake of copyright restrictions, we're hiding the summary, but you see the capability with your own eyes. Okay. Let's ask another question. This time, we're going to ask a question about hardware recommendation. I want to solve a problem. I want to understand which GPU card will help me use the Fluent's native GPU solver with a 10 million cell count mesh for a non-reacting species mixing simulation. Not only does it give you GPU recommendations, it also takes into account your budget and also which GPU cards have been platform tested by ANSYS. So this is a really good summary. Another way you can use ChatGPT is to help troubleshoot errors that you see in your day-to-day workflow. Let's go and see an example. So here we have a licensing error. And apparently the license server cannot be connected. So these are some very exhaustive first steps to diagnose and troubleshoot the problem. I know this from experience. It gives you some good instructions on what you can do to check whether or not you have a connection to the license server, whether it's a firewall issue, whether your configuration file is set up correctly. So again, this was a really nice answer. Now, let's talk about a technical error more on the simulation side. Say, for example, you have residuals converging for a CFD simulation, and you don't know why they're blowing up. Or in this case, with the example question on the screen, even though the residuals were converging, I wasn't seeing a global mass balance. So I went ahead and asked ChatGPT, why is that? Now, if you didn't have privacy concerns, you could also upload your .out file from CFX, and that would give ChatGPT even more ammunition to help diagnose the issue. But because of proprietary reasons, we're just going to ask a generic question. So let me just play this. So it says RMS residuals are algebraic errors, local errors, whereas global mass imbalance is a physical conservation check, which is not the same thing. And then you can see some potential reasons as to why we may be seeing such a high imbalance in our problem. In this case, turns out we weren't setting our boundary conditions correctly by mistake due to user error. Some boundary conditions were incorrectly assigned. But again, this is a very good summary to start diagnosing the problem. Now, we talked a little bit about troubleshooting. We talked a little bit about looking up answers. What about efficiency? Are there certain tasks that you may want to offload to ChatGPT because it's too time consuming? So let me share an example over here where I want to set up a CFD problem and I have restrictions, say for example, through a vent. Now I have the pressure velocity table for that component, and I want ChatGPT to calculate the inertial and viscous resistances that I can feed into my CFD problem. You could apply the same logic for other physics as well. Say, for example, if somebody is doing an HVAC problem and they have certain um, humidity, relative humidity calculations that they have to perform to calculate how much water vapor is there at the inlet, etc. These are simple analytical calculations that you can easily offload to and ChatGPT. So you'll see that I uploaded the PV table. And not only did it give me the values of C2 and alpha, it also showed me how and why and the whole equation. So again, pretty cool. Okay, now let's see an interesting one. And I think this is where you get the maximum use out of your GPT tools. Um, in my experience, AnsysGPT is good at giving you recommendations and guidance based on all the data that it can accrue from Ansys help guides and documentation, but ChatGPT is better at interacting with the problem and actually creating scripts from scratch or fixing scripts or looking up, the latest API syntax, etc., and making sure that you have a pretty robust code. So here we are asking ChatGPT to write a discovery script from scratch to create a geometry and then extract the flow volume from that geometry. So you get a Python script. And then you can just copy this script and paste it in your ANSYS GUI. See if it works. So let's go ahead and try it. So this is my discovery interface. I've opened the script editor. I'm going to copy paste the script from ChatGPT over here and let it run. So you see on the side that a volume was automatically created. It was even given a new name, and pretty sweet. Now, the real advantage of writing codes like this is not that you can create simple pipe geometries that people could, make in their sleep. But the idea is to showcase the functionality of using a script that's customizable. You can, change the dimensions, you can change the parameters. Once the code works, you can easily reuse the script for multiple use cases and projects. So that's the beauty of leveraging AI for automation. I will be transparent that the code snippet from ChatGPT didn't work on the first go. I had to, enter some manual selections in the code and also update some of the attributes consistent with the latest API. But that's okay because for the most part, it was still a pretty robust and efficient code that now works. So, like I said, use ChatGPT or AnsysGPT's responses as a first guess, a first good guess, and then build upon it. Okay. Now, um, let's do an example where we have compound instructions or follow-up questions inside ChatGPT. So say, for example, I have a screenshot from my Fluent window wherein I am looking at the animation of a tank filling problem. It's a 2D problem, some gas and liquid interface being captured. Now, without providing any other context, just this video, I uploaded it to ChatGPT and asked it to either analyze or summarize the post-processing results. So if somebody is new to CFD, they don't know what they're looking at, or they don't know if something's wrong, this is a good way to, get some feedback from ChatGPT about things that you may be missing out on. So it's going to analyze the video and then give us its thoughts on what we're seeing. So it analyzed the frames in the video and correctly guessed that this seems to be a VOF simulation. And then it lists certain key observations like phase distribution, interface dynamics, flow development, final state. And this can help you gain some additional context or insight into your post-processing. Now, what I also did was I uploaded the auto-generated Fluent simulation report to add a little bit more context to my original question. And then I'm asking ChatGPT, hey, do you think there's some siphoning effect going on in this problem? And so it replies with, yes, there is siphoning, and here is why. So you can use ChatGPT almost like a sounding board, where you basically either double check to see if you're on the right path or gain some additional insight that you didn't have originally. So here ChatGPT is writing a custom high-fluent code for me so that I can replicate that auto-generation of a report similar to what Fluent does on its own. But this code now can be customized according to my preferences. I'm not sticking with the defaults. And then I can reuse it for all future CFD simulations. So a lot of coding capability, a lot of automation and customization capability. Of course, be cautious, test it, validate it, see if it works, try to fix it. But after that initial investment, you'll have something that you can reuse for the future, a standardized workflow that perhaps your entire team or organization can use. Now, another way that I've used ChatGPT over here is to just upload an image and then ask if this CFD mesh is decent quality. Pretty simple. Just took a screenshot and uploaded it. Let's see what GPT thinks. The short answer is not yet. There are certain things that are okay, but there are certain things that can be improved. So it's telling me a little bit about the transition being abrupt from the inlet to down to bulk region. And it's also telling me how many boundary layers I should have, maybe check additional metrics to ensure that this mesh can be used. And I really like this last suggestion where it says that use a hex sweep mesh with an O-grid and prisms. That would yield the best results. I agree. So all in all, we saw all these different use cases for both AnsysGPT and ChatGPT. ChatGPT is a little bit more diverse just because it has access to the entire web. But overall, multiple ways of making your day-to-day engineering / simulation easier and faster. So with that, we end today's session. Please let us know if this presentation, webinar, piqued your interest, if there were ways in which you hadn't been using GPT, but now will. Or feel free to even share ways in which you are using GPT that I didn't cover. So thank you, everybody.